is one of the property comes under for your regular expressions. Okay, so how I can denote this x plus y during my set? Okay, so the first option is x. So what is the meaning of the regular expression x plus y is not? What is the meaning of the regular expression x plus y? Either I can read the input symbol x, or either I can able to read the input symbol y. Okay, so that is the condition over here. Okay, so before going to be answering this question, you must know about the Thomson construction. Okay, so already I just explained about what I mean by Thomson construction and all. Okay, so in the Thomson construction, there are three properties, that is union, concatenation, and clean closure. Okay, so what is the first option for this given question? The first option is x. So that it means only x input symbol only coming for the given regular expression. But what is my question? X plus y. So the first option is not a valid answer. So here x plus y in the sense I can read input symbol x followed by either I can read the input symbol y. Okay, so that is the condition over here. Okay, so what is the second option? Only the set only y. So this is also not valid answer. Why? Because here x value should be missing. So the second option is also a wrong one. So what is the third option? X comma y. So this is the correct answer. Why? Because my question is x plus y. So this is nothing but our union concept. So along to the union concept, the both input symbol, either I can be able to read the input symbol x, either I can be able to read the input symbol y. So I can denote the set like as x comma y. Okay, what is the fourth option? Here the included as the epsilon symbol. Okay, so when the epsilon symbol is going to be included in the sense clean closure concept, if it does come the clean closure concept, then only I can able to include the input symbol epsilon. Okay, so the fourth option is also wrong. So you must know about the only x comma y, if it is comes, that is considered as a union related for your question. In case epsilon comes over here in the sense, this should be must be a clean closure. But now my condition is only for the union. So the fourth option is not a valid. Okay, everyone can able to understand. So the given question is x plus y. The x plus y is nothing but your union concept. So once if you are considered as a union concept, either I can able to read the input symbol x, or either I can able to read the input symbol y. So the answer is I can denote the set for the given regular expression x plus y is x comma y. Okay. So next we will see the second question. So the second question is, one second, the question will be loaded. Right. So the deterministic finite automata can be constructed for. How I can construct deterministic finite automata in the sense either regular grammar or context free grammar or context sensitive grammar or undistinct grammar. So you people already know about the classification of finite automata. Okay, so in our finite automata we can able to classify into BFA, and one more for NFA, and one more for us epsilon NFA concept is also available in my finite automata. Okay, so epsilon NFA. So these types of finite automata, how can I going to be constructed? So every finite automata can able to construct by the regular expression, right? So I can use the regular expression using the regular expression. I can construct this finite automata, that is DFA, NFA, epsilon NFA. This is nothing but deterministic finite automata, non-deterministic finite automata, epsilon non-deterministic finite automata. So these types of finite automata everything can be constructed by the regular expressions, right? So how this regular expression is going to be considered? This is nothing but your regular grammar. Okay, so everything you must construct for your finite automata, you must know about the regular grammar. So my finite automata either DFA or NFA or epsilon NFA, everything can be able to constructed through only regular grammar, not for context-free grammar, context-sensitive grammar, and descriptor grammar. Actually, this is nothing but your Chomsky hierarchy of languages. Okay, so these types of questions can able to ask in gate questions. Okay, so how you people are going to be constructed by the finite automata, either regular grammar or context-free grammar or unrestricted grammar, like that they may going to be asking. So what? So the correct answer is regular grammar. So what about context-free grammar? This context-free grammar is nothing but only thing is they may going to be accepted like PDA, like that. You can use context-free grammar. Okay, for your pushed-on automata concept, right? So pushed-on automata can be considered for the context-free grammar. Okay, so what about unrestricted grammar? Well, the people are going to be consider the Turing machine. That Turing machine can be considered for the unrestricted grammar. Okay, so like that, if people must know the Chomsky hierarchy of languages. So once if people are going to be constructed for the finite automata, you must know about the regular grammar. Okay, so in this, the correct answer is regular grammar, not for context-free grammar. So this is for only accepted for the position automata. This context-sensitive grammar is also not applicable, and unrestricted grammar is also not applicable. This unrestricted grammar only applicable for your Turing machine. Context-free grammar and context-sensitive grammar should be applicable only for the position automata. Okay, so this is one of the, they may ask in the gate. Okay, so try to remember. So next question. All right. So this is my third question. So the minimum number of states required to construct a DFA for the language. Right. So the question is the minimum number of states required to construct a DFA for the language L equal to a power n such that n greater than or equal to 4 years. So how many number of states I'm just to consider for the given language? That is the question. You must remember what is your language? A power n such that n greater than or equal to 4. What is the condition over here in the sense? The first value must be n should be 4. Okay. So in this case, you must know what is the first string of the given language. So what are the language? What are the strings can be generated for the given language? First, you have to know that one. So my language is L equal to a power n such that n greater than or equal to 4, right? So the first value is what? N equal to 4. Okay, why? Because the condition is n greater than or equal to 4, not n greater than or equal to 1. Okay, so the first value is n equal to 4. So what is the value? While I'm going to be applying the 4 for my a power 4, so thus I can apply the value for n to my a. So how many values I will get? 4a I will get. So according to the given language, the first string is 4a. Okay, what is the condition? N greater than or equal to 4. First I just going to be applying the value. First I will apply the value 4 to my n. Again, this is also possible. N equal to 5. Is it right one, right? Why? Because n greater than or equal to 4. So 5 is also applicable. So 5 greater than or equal to 4. Condition is true. So what is the value for now? N a power 5. Is it right? So a power 5. So how many a's should become over here? 5a will become. So like that, you can generate the string for the given language according to the value of your n. Okay. So up to this one going to be until infinity strings going to be generated for the given language. Okay, so the string generated for the given language is 4a. For simply understanding, 4a, 5a, 6a, 7a, like that you can generate the strings in the given language. So what is my question? The minimum number of states required. How many states I need? Minimum number of states I need to construct the DFA. Okay. Which kind of language? This is my language. What is the first string of the given language? The 4a. What is the length of the string? 4a. So this is the 4. So length is 4. So I want to construct DFA for the first string. How many states are required? So just listen. First state, second state, third state, fourth state, fifth state. Okay. So this is my start state. I want to read the input symbol A, followed by A, then followed by A, then followed by A. Okay. So this is my accepting state. I just indicated the double circle. So this is my accepting state. It means this is my language L equal to a power n such that n greater than or equal to 4. This is my language. First of all, I want to know what are the strings generated for the given language. So the first string is 4a. Okay. So for my convenience, I just represent the numerical value over here. Okay. So 4a, 5a, 6a, 7a. Those types of a going to be generated for the given language. The first string is 4a. Okay, so those 4a, I want to construct the DFA in the sense minimum I required 5 different types of states. Okay, so I just mentioned the value. This is state number 1, this is state number 2, this is state number 3, this is state number 4, this is state number 5. So what is the minimum required number of states to accepting the first 4a? Totally 5 states. Okay, the answer is 5a is the 5 state is the correct answer. So 3 is also 3 is not correct answer. 4 is also not correct answer. 6 is also not the correct answer. Right? So why I just say the 5? The input stringers, the first stringers for the given language is 4a. So 4a I want to accept in the sense I need 5 states. Okay. So what is the length of the first string is 4. So now you people don't understand about the length and all. Okay. Once I want to accept this 4a in the sense I need 5 states. Okay, in case I want to know, I want to accept the 5 in the sense you can put it as a self loop over here. So now in this case, this is the finite automata for the given language. Okay, so in this finite automata now accepted for the 4a, 5a, 6a, 7a. So every number of a's can be able to come over here. Those finite automata are going to be accepted. So how many states I required here? Only 5 states, not more than that, as well as not below 5 states. Okay, so the minimum number of states required to construct the DFA for the language L equal to a power n such that n greater than equal to 4 is 5 states. Okay, in case suppose my condition is not, suppose my condition is 3, right? Okay, my condition is what? 3. So now you just tell me what is the minimum required, what is the minimum number of states required to consider the DFA now? 4 is the correct answer. Why? Because the condition is n greater than equal to 3. So the first string is 3a should be come over here. Okay, so 3a I want to accept for my finite automata in the sense I need 4 state. Okay, so those kind of questions also asking in our gate examinations. Okay, you must know what you know. First of all, you must understand the language. According to the language, what are the strings can be able to generate it. In the generated strings, which one is the first string? For the first string, you have to consider the DFA. Okay, so that is the minimum required number of states. Okay, so you have to remember, about the language as well as strings and all. Okay, so this is the one of the question asking in our gate. Okay, so this type of question they may going to be asking. Okay, so next one. So this is somewhat interesting, this problem. Right? So this is the question. So just listen the question. The input accepted by the DFA, that is finite automata, Q0, Q1, Q2, A, B, transition, Q0, Q2, where transition is given as Q0, B. When I just give the input symbol B from Q0, it reaches as a Q0 state. While read the input symbol A from state Q0, it will be reached as a Q1. In case I read the input symbol A from Q1, it reaches as a Q1 state. If I read the input symbol B from Q1 state, it reaches as a Q2 state. If I read the input symbol A from Q2 state, it will be read as a Q1 state. If I read the input symbol B from Q2, it will be reaches as a Q0 state. Okay, so for this DFA, which input accepted for the automata? That is the question. Okay, the option is triple A, triple B, AB, and second option is ABA, BA. Third option is triple B, double A, double A. Last option is double B, double A, double B. Okay, so now we will see the concept. Now you must know, I think everyone can remember about the DFA tuples. Okay, so what is the tuples along with your DFA? DFA, what is the tuples? The 5 tuples should be available, right? So that is capital Q, your alphabet, your transition, your start state, set of accepting or final state, right? Everyone can able to know about this 5 tuples. Okay, so this 5 tuples only represented for the given question. So what are the set of states here? Final set of status, this capital Q. What is the state? Q0, Q1, Q2. Okay, so what is the set of alphabets? A, B. So this is the thing, everyone, you have to know this one. So once you people don't know about the how to represent the tuples, that's very tough. Okay, so what is the transition? This transition only they may given like this one. Okay, so this is the transition. Okay, so my start state is Q0. So here you just see this Q0 is my start state. Okay, so what is the set of accepting state? Here Q2, they represent the Q2. So my accepting state is Q2. Okay, so according to this given data, I want to construct the DFA now. Okay, so how many states over here? Q0, Q1, Q2. Just I construct over here. This is my Q0. This is my Q1. This is my Q2. Okay, so this is my state. Why I just going to be representing over here in the sense they may given the transition. Okay, so once if you people know about the transition diagram of your given question, it will be very easy to say the answer. Okay, so according to the given condition, the start state is Q0. I want to represent this starting symbol, that is empty arrow mark. I want to put it as a Q0. Okay, which one is the ending? Which one is the accepting state? Q2. So you have to put it as a double circle for the Q2. Okay, so before going to be processing this problem, you have to know here Q2 is your accepting state, Q0, Q1 is your non-accepting state. Okay, now you just say, you just listen over here. While I just read the input symbol Q0 to B, from state Q0, I will be read the input B, where it will go Q0. So you put it as a self loop B. Okay, so from Q0, I will read the input symbol A, where it will go Q1. So from Q0, I just read the input symbol A, it reaches as a Q1 state. From Q1 state, I read the input symbol A where it goes Q1. So it will becomes as a self loop. So what is the input symbol? Small a. So next one is from Q1 state, I read the input symbol B where it will go Q2. So Q1 state, I read the input symbol B, it reaches Q2. Okay. From Q2, I read the input symbol A where it will be moved Q1 state. So just listen here. From Q2, I read the input symbol A, it will be reaches state Q1. Okay. Again, from Q2, I read the input symbol B where it will go Q0. So from Q2, I just read the input symbol B, it will be reaches Q0. Okay. Everyone can able to understand? Students, can everyone can able to understand this one?
Yes, sir.
Right. So this is my DFA.
Yes, sir.
This is my tuples available in my DFA. So with given the question, I just represent what are the things available over here. Okay. This capital Q is nothing but your set of state. What is your set of state? Q1, Q1, Q2. This is your given question. Okay. So this is nothing but your alphabet. Okay. So finite number of alphabet. Okay. What is your alphabet? A comma B. That is your input symbol. Okay. So what is your transition? The transition already they given. Okay. So which one is the start state? Q0 is my start state. Which one is accepting state? Q2 is your accepting state. Now I want to tell given option, that is four options they were given, right? So which one of the input accepted for the given, which one of the input should be accepted for the DFA, right? So now first we will see the D option. What is my input string? B, B, A, 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 B, B. Okay, so this is my string now. Okay, you just check it. So first input symbol B, right? What is the starting state? Q0, right? So your start state is Q0. From Q0 state, I just read the input symbol B where it goes Q0. Again, Q0 state, I will read the input symbol B where it goes same Q0. From inputs, sorry, the state Q0, now I just read the input A where it goes from state Q0, I read the input symbol A where it will be reaches Q1 state, right? From Q1 state, I just read the input symbol A where it goes the same state, that is Q1 state. From Q1 state, I read the input symbol A where it reaches same Q1 state. From Q1, I read the input symbol B where it goes Q2 state, right? From Q2 state, I read the input symbol B where it goes, just see over here. From Q2 state, it reaches B where it goes, Q0 state, right? So this is the finally input symbol B, it reaches the state Q0. What is the Q0 state? It is non-accepting. Okay. So this input can't able to accepted in my DFA. Okay. Students, can everyone can able to understand? So according to the given DFA, now I
Yes,
want
sir.
to say which input accepted for the given DFA. Okay, so the fourth option is not valid. Okay, so this thing is not accepted for the my DFA. Okay, so just take second the C option. What is the B option? C option? Triple B followed by AA. Okay, now we will see that one either accepted for the my DFA or not. Okay. So what is the input now? My input is B, 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 A, 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 A. Okay. So now I want to check whether this input accepted for the DFA or not. Okay. How I can able to check? What is my initial state? Q naught. Okay. So my start state is Q naught. So from Q naught state, I just read the input symbol B where it goes same state. Okay. So it goes same state Q naught. From Q naught, I read the input symbol B where it goes the same state. That is self loop, right? From Q naught, again I just read the input symbol B where it goes same Q naught. Now just listen, the input symbol is now different. What is the input symbol now? A. From Q naught, I read the input symbol A where it goes Q1 state. Okay, so where it goes Q1. Again, I just read the input symbol A from Q1 state, again where it goes the same state, that is self flow. Okay, so where it goes Q1. Again, from Q1 state, I read the input symbol A where it will be moved Q1 state. Again, from Q1 state, I read the input symbol A where it goes Q1 state. So this Q1 state is not my accepting state. This is for non-accepting state. So this thing is also not accepted for the my finite automata. Okay. Everyone clear about this? Students, everyone can able to understand. Okay.
Yes,
So what is
sir.
the next option? ABA, BA. Okay. So now I just check that one. The input string is ABA. ABA. Just B. Now this string will check whether the given DFA accepted or not. What is the string now? A, B, A, B, A. Okay. So again, I will just going to check whether the input accepted for the given automata or not, right? So what is my first state? Q naught. This means start state, right? So from Q naught state, I just read the input symbol A where it will go Q1. Okay. So from Q naught state, I just read the input symbol A, it reaches Q1 state. From Q1 state, I read the input symbol B where it will be moved Q2 state. From Q2 state, I read the input symbol A where it will be go. See, from Q2 state, I read the input symbol A, it will be reaches as a Q1 state. From Q1 state, I just read the input symbol B where will we go Q2. From Q2, I just read the input symbol A where will we go. Just to see here. From Q2, I read the input symbol. I'm sorry. Here I made mistake. Just listen. From Q2 state, I read the input symbol A. From Q2 state, I read the input symbol A. Okay, Q2. Okay, from Q2, I read the input symbol A. It reaches Q1, right? Nothing wrong. From Q1 state, I read the input symbol B. It reaches Q2. From Q2 state, I read the input symbol A. It reaches again Q1. Okay. So from Q2 state, again I want to read the input symbol A. It reaches Q1 state. So Q1 state is also not accepting state. This is my non-accepting state. So this string is also not accepted for the constructed DFA. Okay, I think everyone can be able to understand, right? So what is the remaining string? Triple A, triple P, AB. Now we will see this string. Right. What is the next thing? A, 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 B, 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 A, B. What is our starting state? Q naught, right? So Q naught is my start state. From Q naught, I just did the input symbol A where it will be reaches Q1 state. From Q1, I read the input symbol A where it will be go same state. From Q1 state, I read the input symbol A, same again, same state. From Q1, I read the input symbol B where it will be move Q2. From Q2, I read the input symbol B where it will be go Q0. From Q0, I read the input symbol B where it will be go same state, that is Q0. From Q0, I read the input symbol A, it will be reaches Q1 state. From Q1, I read the input symbol B where it will be go Q2. So that time I just stopped my string. So now I got it Q2. So this is my accepting state. Okay. So triple A, triple B, AB is the only input accepted for the given automata. So this is the answer. Triple A, triple B, AB. So this is a valid input should be accepted for the given DFA. Okay. So this is the so according to this only you can able to consider. Okay. So normally everyone can able to say by orally you can by orally we pass the string in this finite automata we can able to easily tell, but have to work out like this. Okay, but you have to work like this way. Okay, so in this question, that is the input accepted by the DFA. Which one is the input accepted for the given DFA? WA, AB, AB. So this is a valid input for the given automata. Okay, students, everyone can understand how this flow going to be occurred in the finite automata and all. Okay, so
Yes,
next
sir.
question, that is final question. Now this question you just look at. So in this question, I want to write the regular expressions, denote the language L over an alphabet A comma B, such that the string do not contain the substring AB. The thing is, you can generate whatever may be the string for the given language. Okay, but the substring AB doesn't able to come for the in your regular expression. Okay, so the languages they denote some language, that is what is your alphabet A comma B is your alphabet. Okay, so just listen. So what is your alphabet? A comma B. Okay, you can generate whatever may be the string. Okay, so that is nothing issue, right? So along with the given alphabet, you can generate whatever may be the string, but the thing is the substring A B not comes. So according to that, you have to consider. Okay, so A B substring not comes for your regular expression. That is that particular string not accepted for the regular expression. Okay, so for that, how we will going to be solved now? So everyone can able to understand the question. The question is AB is a substring. That AB substring not contained for the given language. That is the question. Okay. So for that, what is the option? Now we will see that one. Okay. So first you have to check A star, B star. Okay. So what is A star, B star? Okay, so this is nothing but your clean closure property. Okay, so before going to be consider A star, B star, what is the value for A star? What is the string generated for the A star? This is nothing but zero or more occurrences, right? So once we are going to be mentioning the star, that is nothing but your zero or more occurrences. So that is called it as a clean closure. Okay, so in this A star, I will get at the string. First string is epsilon. Why? Because zero or more occurrences, right? So zero or more occurrences, you have to mention epsilon. Okay, so followed by 1A should become WA should come, 3A should become, like that you can generate the A's the given A star language. So this is your language. A star is your language. From this language, I just generated the string epsilon A, double A, 3A, 4A, 5A, like that you can able to generate. Okay. Now what is the condition? A star, B star. Okay. So A star, B star in the sense, what are the string can be able to generate for the A star, B star? Now you just check A star, B star. Okay. So what is the first string?
Epsilon.
So first string is epsilon. Why? Because my property is clean closure. That is, instead of plus, I just mentioned the star. Okay, so once the star comes in the sense, that is called it as a zero or more occurrences. Zero in the sense you have to mention the epsilon input symbol. Okay, so what is the string going to be generated for this one? I can generate the A, or either I can able to generate D, or AB. I can also AB also can able to generate, right? So because the first string is A, definitely A should be followed by B only, right? Right or wrong?
Right, sir.
So once if you are going to be start the string A followed by B only. Okay. So here I got the AB as a substring. Okay. So definitely the first option is not is the correct answer. Okay. So why? Because from the A star B star language I got the substring AB, but condition is do not contain the substring AB. So the first option is wrong one. Okay. So what is the second option? B star A star. B star A star. What is the string generator for this given language? First string is epsilon, right? So second string you can say either B or A, or A or BA is also accepted, right? Right or wrong?
Yes, sir.
BA is also accepted, and also B is also accepted. B BA also accepted, right? Double B WA is also accepted, right? So according to the given condition, these are all the strings can able to generate it. So in the string, that is, in the generated strings, there is no AB as a substring. Why? Because the first string is B. Only the B. Once if here comes B followed by only A. Okay. Either according to the given language, either epsilon is also accepted, either B also can accept it, A is also accepted. That is not the condition. My condition is the substring AB not contained for the given language. Okay, so BA is also accepted, BB is also accepted, BBA is also accepted. So whenever people are going to start with A, only comes what comes for A only. Okay, so if you have any kind of confusions, you just go through for your Thompson construction. Okay, so already people know about the Thompson constructions, right? So you can construct a B star A star, you can know. Okay, so B star A star, when we will see the Thompson construction in this space, right? So better if people understand. If you understand the Thompson construction, it is easily can able to say the answer. So what is the Thompson construction for this B star A star? Let me draw the diagram. So B. So this is B. Okay. B star epsilon epsilon epsilon. It will be reaches as a accepting state. So this one everyone know, right? So this is B star, right? So what is followed by A star, right? So A star you can be able to construct like this one. So this is A or B epsilon. So this is epsilon. Right now you can connect this one by the way of one new start state. Okay. So this is epsilon. Okay. So this is Thomson construction. Okay. So the Thomson construction for B star A star like this only. Okay. So now you just consider the input. Okay. So according to this Finite Automata, it just tell what are the strings can able to generate it. So either B or A, right? Okay. So in this case, you must know how to generate the string for the given epsilon NFA. Okay. So what are the strings can you able to generate it? So either just see over here. This is B star, this is A star. Okay. So I can say the string like B is accepted, A is also accepted, B accepted, again B A number of A's. So in this case, it just listen. So in this case, double B accepted as well as double E accepted. So this type of strings can be able to only generate for the given automata. Okay. So like that you can able to be like that you can able to generate the strings. Okay. So according to this, the string. According to this, what are the strings can be able to generate like this string only going to be generated. Either BA is also accept B only A, not combination of B and all. Okay. So this is my Thomson construction. Okay, this is my Thomson construction. Okay, so this is the string can be able to generate it. Okay, so what is the next option? AB star. AB is in the sense definitely here AB should be come over here. So AB come in the sense definitely the substring AB will become. So this is also not the right answer. Okay, what about BA? So BA whole to the power star. So this is nothing but what is this? This is concatenation. Okay, so already told about for the properties of regular expressions. One is union. Next one is concatenation. Concatenation. Last one is screen closure, right? So these are the three different types of properties available in your regular expression. Okay, so already told about the union, that is we consider the first person express y, right? So next one is concatenation. So in this case concatenation will be comes over here A B. So this is nothing but a concatenation A dot B. Okay, so in this case definitely this should be represented as a AB. Okay, so surely the substring AB should be comes over the AB star. So BA whole to the power star, in this case also AB should be contained. Why? Because if people are going to be considered BA whole to the power star for the Thomson construction, definitely AB as a substring should be come. So which one is the correct answer? B star A star is the correct answer for the question. Okay, so if you people are going to be approaching this type of the problem, you people must know about the Thomson construction. I'll try to explain about the Thomson construction, how to consider the union, how to consider the concatenation, and how to consider the clean closure and all. Okay, once you people are know about the particular Thomson construction, you can easily tell the answer. This type of question, you can tell the answer very, very easily. Okay. So anybody having doubt for this? Right? Anybody having doubt for this?
No, sir.
Now you can construct the AB O to the power star for the Thomson construction. Better you can able to understand. So now I just going to be consider. Now I just going to be draw the AB O to the power star. Okay. So better you understand that particular regular expression not comes for the answer. So what is the operations? Here the two different types of the properties takes place. One is concatenation, one more is clean closure. So I just draw the diagram. You just see this. So AB whole to the power star in the sense only epsilon is also going to be accepted, right? But that one I just construct AB whole to the power star. You just look at AB, not AB star. This is AB whole to the power star. The concept is different. Okay, so I just construct AB. Okay, so this is A. This is B. This is epsilon. So in this case, epsilon symbol also going to be accepted. Okay, so for that I just included one more. I just included two more states. Okay, so this is possible. So these all comes for you. These all comes under for your constant considerations. Don't confuse. Okay, so why I just going to be draw this one for your better understanding for that for your better understanding. That purpose only I just draw this one. Okay, so everything should be mentioned as a epsilon. So in this, so see in this string, in this regular expression, the first string accepted for your epsilon. Okay, so next one is AB is accepted. Okay, so I can able to read like this way. Okay, so this is the starting state. So this is your accepting state. Okay, so AB, I just read once again AB, once again I can able to read AB. Okay, so this type of string can able to generate it for AB. Okay, so my substring AB should be comes under over here. So thus AB star O to the power star is not a valid string. Okay, so next one is, so everyone can able to understand AB star. So once we are going to be say the concatenation, you can draw like this way. Okay, so BA star. Actually, I think BA star is the correct answer. So BA star in the sense instead of followed by B. So just see over here. Here I put it as B. This is A. Okay, so in this case, the first string is epsilon going to be accepted. Second string is BA accepted. Again, BA is accepted. So this kind of thing is going to be accepted for the BA star. Okay, so actually this is the right answer. BA star is the right answer. So what about the B star A star? This is the wrong answer. I just explained. How can I construct the B star A star in Thomson construction? Students can, everyone can able to understand. The answer is BA O to the power star, the correct answer, not for B star A star. Now I just going to answer the B star A star. Now we will look, right? So B star BA O to the power star is the correct answer for the given question. Okay. So now I just going to be consider B star A star. Now we will see. So B star A star in the sense the first string epsilon going to be accepted, right? Now I can construct. So this is A. Followed by B star, right? Okay, right. So this is A star. Sorry, this is B star. V star again followed by A star. This is also concatenation, not for a union. Okay, you can construct A star once again for this way. Actually, two answers both are. Okay, this is A star. Connect. You just make connection for this. This is epsilon. This is start state. This is accepting state. Okay, so from this you can make it epsilon. So this is B star A star. So in this epsilon NFA also there is not contain AB. So actually this answer is also correct one. Okay, so in this regular expression in this given language, I can accepted the epsilon B followed by A or B A accepted or B A accepted or B A is also accepted. In this also there is no in substring AB contains. Okay, so in this case this string is also correct one, this also is also correct one. Okay, so B is also right. B
Sir,
yes.
sir, இப்போ BA old the star AB வந்துச்சு சார் சப்ஸ்ட்ரிங் BA BA வந்துச்சு சார்.
Yes.
சார் அப்ப அது வரும்போது AB சப்ஸ்ட்ரிங் அதுல வருதுங்க சார். சோ அது கரெக்டா இருக்காது சார் கடைசி ஒன்.
Okay, BA star is the not right answer. Okay, so while we are going to be consider the BA O to the power star, so this is not correct answer. So the correct answer is B star A star is the correct answer. So in this B star A star that is not contain the substring AB. Okay, right? So I hope everyone can able to understand this one. Okay, so rest of the things we will see in the next class. Thank you.